All right. So as we're working through problems, what's important when we're doing that? Well, it's important to keep track of your components, terms, and factors. So I talk about problem structure. It's the way in which the steps to evaluate an expression are written to efficiently keep track of the separate terms and factors as you work. So when I do math, I know that, or when I work on math, when I calculate math, I know that the terms and the factors are the most important components, the pieces. So as long as I keep track of those as separate components, then I should be all right when I evaluate. So that's what we're going to do here. How do we write math to efficiently keep track of terms and factors? And we already have been practicing it basically. When I look at an expression, I'm going to evaluate it. The first thing I'm going to do is look at the separate terms. So I'm going to keep these separate terms in their columns until I know their term values. So here I have 3 terms. As I work with each of the terms, I'm going to use now factor notation. So what are the factors of the first term? So again, we have this negative sign in front of the parentheses. So the factors are going to be -1. Okay, we're going to use -1 to represent that factor. And then I have -2 cubed. So I could write out -2 times -2 times -2. These are all the factors in that first term. And I can evaluate the term value by just multiplying these factors. -1 times -2 is +2. -2 times -2 is +4. But what I want to do is get the term value. 2 times 4 is +8. The term value is what I want to keep track of. So once I'm done calculating that, I know I want that term value. Okay, now I'll go ahead and work with the second term. The second term in this column, I'm just going to keep track of this term, but again, I have the negative sign. Outside of grouping symbols, notice I have this +3 squared. So this would be a factor of -1. And then 3 squared, I could just keep track of that value as another factor of +9. -1 times 9 has a term value of -9. And again, as long as that term value is in that column, I'm keeping track of it. The third term is the square root of. Now this is a grouping symbol, so I need to find out the value inside. That'd be the square root of. 25 and -16 is +9. So again, this term value, the square root of 9, is +3. So the columns are keeping track of my terms. Again, you'll get used to like making more space, because space doesn't matter in math. What matters are the separate terms and factors. So once we have our factor values, now we can combine those values. So 8 and -9, maybe we can put those together. Or if we wanted, we could put the 8 and the +3 together to get +11. And then I have this -9. 11 and -9 is 2, and that would be my term or expression value. But composition of math, it breaks up the expressions into components. So let's see the difference. And if you notice, this next expression has a lot of the same things involved. I see this -2 cubed, I see the square root of 25 minus 16, but the composition is different, and what I need to keep track of is different. So in this one, in this expression, you notice there's only one term. Now, what that means is that if there's just one term, then everything are factors. I need to keep track of factors. So if you think of just taking this term and looking at the factors, what do I have? Don't evaluate anything, just look at the factors. Well, I have this negative sign in front. That's a factor, and I know the value is -1. Now, the set of parentheses is identifying another factor, but it's -2 cubed. So what I want to do is keep track of that factor value. So I'm going to, as one factor, I'm going to group this together. -2 cubed would be a -8. So if we want to evaluate that, what I care about is to keep track of factor values. But again, these are all factors, so I'm using parentheses to keep track of those factor values. So the parentheses here are signifying another factor. So I need to keep track of that factor value. Well, -3 squared is the same as -3 times -3, which is a +9. And again, I'm keeping track of it as a factor. Same thing here, it's another factor, the square root of 9, 25 and -16, but I need to keep track of this as another factor. So the square root of 9 is 3. Once I have all my factors, I can start multiplying. So -1 times -8 is 8 times 9 times 3. Well, 8 times 9 is 72 times 3, which would be 200, no, excuse me, yeah, 216. So without going through the details there. But the big thing is just using the composition and then problem structure to keep track of those components. So here I had 3 terms. I needed to keep track of those 3 terms. Individually, I used columns to do that. From the start, right, I had 3 terms. So I know it's important to keep those 3 terms and find those term values. This expression has 1 term. So everything that I'm calculating and separating are factors. So the key here is to keep track of factor values. And once I have factor values, I am multiplying. Okay,